A very good morning to all children. Today's class we will discuss about light in physics for grade 7. So in this lesson we will discuss what is called light. Okay. So the topics included in this lesson is first, light travels along a straight line. How light travels? Light travels along a straight line. So and the next one, what is called lateral inversion of light. Then we will discuss about spherical mirrors. Spherical mirrors are categorized into two types. One is concave mirror and the other one is convex mirror. Okay, concave mirror is nothing but it is a mirror in which the reflecting surface is curved inwards. Okay, in the case of convex mirror, the reflective surface is bulges outwards. So this is about spherical mirrors. And next we will discuss about what is called lens and what are the types of lens. Like spherical mirrors, lenses are also categorized into two types. One is concave lens and the other one is convex lens. And finally we will discuss about sunlight. Either sunlight consists of a white light or a colored light. Okay, come children, let us see the topics one by one. So what is our name of the chapter? It is light. First of all, what is mean by light? What is called light? Light is nothing but it is a form of energy. Okay. So what is called light? It is a form of energy. What is the use of light? Which enables the things around us. Okay. So with the help of light we can see the things around us. So that is called light. So light is nothing but it is a form of energy. Okay. Come children. What are the five sense organs? We have five sense organs, no? What are the five sense organs? Sense of smell, sense of touch, sense of sight, sense of taste and sense of hearing. So a beautiful world is known through the senses. So sense of sight is the most important sense which enables us to see the things around us, isn't it? See, a phenomenon of a reflection of light enables us to see the things around us. So which phenomenon is related? Reflection of light. See, there are some pictures are given. These are all the examples of reflection of light. Okay. So what phenomenon is associated with the light? A reflection of light. And light travels in a straight line. Look at the picture. How they travels? They travels in a straight line. Okay. The next one. Is it possible to show that light travels in a straight line? How does the reflection of light occur? What happens when light falls on a mirror? Okay. What happens when light passes through the mirror? See, to know the answers for all these questions, let us study in detail. Our first topic is light travels along a straight line. How light travels along a straight line? Let us see one video about light travels along a straight line. See the video carefully, children.
What is light? In a dark room, we are unable to see anything. But in a bright room, we are able to see everything around us. Light is a form of energy which makes things visible. Do you know where do we get light from? During the daytime, the sun acts as the natural source of light. For light, man has invented many sources of light such as an electric bulb, torch, candles, oil lamps and many more. Let us now understand light in detail. Light from the source spreads out in all the possible directions. Do you know how we are able to see the things around us? When light from sources of light enters our eyes, we see the things. This light can be emitted by the object, as in case of an electric bulb, or from the whirling be the light bouncing off an object like book kept on the table. The light emitted from any of the light source can never travel in a curved manner around the object. Light travels along straight lines in medium or in vacuum. The path of light changes only when there is an object in its path or where the medium changes. We call this rectilinear propagation of light. When you switch on a torch in the dark, light appears to go straight upwards. Also, light from the cine projector takes straight path to the screen. These observations also show that light travels in a straight line. Let us.
So from these activities, it is clear that light travels in a straight line. When will the path of the light changes? When an object is placed in front of the path of the light, it will changes. Okay, so the light travels along a straight line path. The next one. Do you know how the path of light can be changed? The direction of light can be changed by placing any shiny surface in its path. Say some example of shiny surface. A mirror is acting as a shiny surface. See, a shiny surface can act as a mirror. Okay. The next topic is what is called reflection of light. Okay. The reflection of light is nothing but it is a phenomenon. It can change the path of light. That is called reflection of light. So what is reflection of light? It can change the path of light. That is called reflection of light. See, look at the picture. This is a mirror. Okay. See, any smooth polished surface which can return the light, a ray of light into the same medium is called as a mirror. Okay. So any shiny surface act as a mirror. What is the use of mirror? It can reflect the ray of light. So that is called as a mirror. What are all the examples of mirror? See, looking glass, polished metal surface, still water are the examples of mirror. Why? Because it reflects the ray of light. So it is known as mirror. The next one. What are all the uses of plane mirror? See, plane mirror is used in showcases as looking mirror, in periscope, in kaleidoscope and in solar cooker. So these are all the uses of plane mirror. And the next one, what are all the types of images? There are two types of images. One is real image and the another one is virtual image. Okay, so what is called real image? We can capture or obtain this real image in the screen. So that is called real image. What is called virtual image? We cannot capture or we cannot obtain the image in the screen. That is called virtual image. So these are all the two types of images. Okay. Let us see one video about real and virtual images.
We don't forget to admire ourselves in front of mirror every day. Our image formed in the mirror appears as if we are standing behind the mirror. The mirror we use at home for dressing up is plain mirror. If we place a screen at the back of the mirror, the image could not be obtained on it. Even if we place the screen in front of the mirror, the image could not be obtained on it. If the image formed in a mirror could not be obtained on the screen, the image is said to be virtual. Virtual images are generally formed by plane and convex mirrors. The convex mirror, the size of the image formed is smaller than the size of the object. Therefore, it is used as Because of this property, convex mirrors are also used in security mirrors, used in shops, malls, metro stations, etc. On the other hand, images formed by the concave mirror can be obtained on the screen. This means it forms real image. Concave mirrors are used by the doctors for obtaining the enlarged images of inner view of the objects. Therefore, these are used by dentists and in reflectors for torches and headlights in vehicles.
So we can obtain the image on the screen, or if it is real image, now we can obtain the image in the screen. If it is virtual image, now we can't obtain the image in the screen. So these are all the two types of images. Okay. The next one, lateral inversion. What is called lateral inversion? It is nothing but the phenomenon due to which the right side of the object appears as left and the left side of the object appears as right. That is, the image is inverted sideways. Okay. So it is known as lateral inversion. Okay. And the next one. See, do you know why the word ambulance is written in a strange manner? This is due to the phenomenon of lateral inversion. Okay. When the driver of the vehicle ahead of an ambulance looks in the rear view mirror, he finds the correct word ambulance. So in the rear view mirrors, the objects are closer than they appear to be. Okay. So this is an example for lateral inversion. And the next one, playing with spherical mirrors. Next we will discuss about spherical mirrors. Spherical mirrors are actually mirrors. They are spherical in shape. So due to this reason only they are known as spherical mirrors. These spherical mirrors are categorized into two types. One is concave mirror and the another one is convex mirror. See, due to their spherical shape, they are called spherical mirrors. Spherical mirrors are of two types. What are the two types? One is convex mirror and the another one is concave mirror. What is called concave mirror? See, a concave mirror is a mirror. It is a curved mirror whose reflecting surface curves inwards. See, look at the picture. This is the reflecting surface. Okay. So, in a concave mirror, the reflecting surface curved inwards. It's like a cave. And the second type is convex mirror. What is called convex mirror? It is also a spherical mirror in which the reflecting surface bulges outside. Okay, that is called convex mirror. See, it is a curved mirror in which the reflecting surface bulges outwards. So, these are all the two types of spherical mirrors. And the next one, curved surfaces form different type of images. Let us study the image formation by concave mirror. So what is called concave mirror? It is a spherical mirror in which the reflecting surface curved inwards. This is about concave mirror. How images are formed in the case of concave mirror? See, take a concave mirror, place a screen at some distance in front of this mirror. Allow the sun rays to fall on the concave mirror. What will happen? By adjusting the concave mirror until a sharp bright spot is obtained on the screen. Okay, so this is an activity. See, this is the concave mirror. When a light rays passes through the concave mirror, we can get the image in the screen. Okay. What did we observe? What did we observe? See, the bright spot on the screen is the image of the sun. The image is formed on the screen in the case of concave mirror. Can you recall what are the images formed on the screen known as? Yes, it is known as real image. concave mirror. Place the lit candle at a distance about 50 centimeter in front of the concave mirror. Place the screen in such a way that the clear image of the candle is formed. See, this is an image of the candle. How it looks like? It is inverted. You can get the inverted image of the candle. Okay. And the next one, what did we observe? In this case, we observe that the image of the candle formed on the screen is real and inverted. So we can get the inverted image. Okay. And the same experiment is done. Now bring the candle closer to the concave mirror. What we can observe in this case? What did we observe? We observe that the screen has to be moved further. Thus the object comes closer to the mirror. The image moves away from it. Also the size of the image on the screen increases. So we can get the large image of the object. Okay. Again bring the candle closer to the concave mirror. This is the fourth case. Now we are bringing the candle closer to the concave mirror. Is there any image we can obtain in the screen? No, we can't see any images. Okay. So what did we observe? In this case, we observe that it is not possible to obtain the image of the candle on the screen when it is too closer to the concave mirror. Can you recall the type of image which cannot be obtained on the screen? So what is the type of image here? We can get virtual image. Why? Because we can't obtain any image on the screen. So it is a type of virtual image. So from these activities, it is clear that in a concave mirror, depending on the position of the object, the image of an object can be real, virtual, enlarged, diminished, not small, same size as that of the object, erect, straight and inverted. So real image is always inverted and virtual image is always erect. Erect means straight. Okay, make a note of it. Real image is always inverted and virtual image is always erect. Okay, so this is about concave mirror. What are the uses of concave mirror? See, concave mirrors are used in solar, in circles, in telescope, in torch and shaving glass. See, these are the uses of concave mirror. And the next one, image formation by convex mirror. What is called convex mirror? It is a spherical mirror in which its reflecting surface bulges outwards. It is known as convex mirror. See, the previous activities can be repeated by now taking the convex mirror. Okay. See, take a convex mirror. We will do one activity related to convex mirror. Next, to place a lit candle in front of a convex mirror. Do we get any image on the screen? No, the image is not obtained on the screen even if we shift the candle to different position. So if the image is not obtained on the screen, it is known as real or inverted. Real or virtual image. It is known as virtual images. We cannot capture an image in the screen in the case of virtual image. Okay. So what is the conclusion? In a convex mirror, the image of an object is formed is virtual, diminished and erect. We can get the straight image. So it is known as virtual image. Convex mirror always forms a virtual image. Okay. And what are the uses of convex mirror? It is used in a rear view mirror in vehicle, security mirror in shops and vehicle inspection. So these are all the uses of convex mirror. The next one, image formation by lenses. Okay, like spherical mirrors, the lenses are also categorized into two types. One is concave lens and the other one is convex lens. Come children, let us study about the image formation by lenses. Okay. What are spherical lenses? A spherical lens The next one, see, look at the picture. It is a convex lens. So what is called convex lens? It is thicker at the center but thinner at the edge. See, this is center, these are all edges. So it is thicker at the center and thinner at the edge. It is known as convex lens. And the next one, convex lens is known as converging lens. Why? Because it converges the beam of light. Okay. See, as convex lens converges the rays of light falling on it, so it is known as converging lens. Okay. Why it is known as converging lens? It can converge the beam of light, so it is known as converging lens. Okay. The next one, see how it converges the beam of light. Take a convex lens and place it in the path of light rays. What will happen? We observe that when a convex lens comes in between, it can converge the beam of light. Also, after some time, the paper starts burning where the bright spot is formed. Why? Because it can converge the beam of light. So, it is known as converging lens. Okay. And the next one, see, this is a convex lens. When a light rays passes through the convex lens, what will happen? It can converge the beam of light. See, all the rays will meet in one point. So it is known as focus of the lens. Okay. So light rays converges at here. So it is known as converging lens. Okay. And the next one, concave lens. What is called concave lens? Look at the picture. It is a schematic diagram for concave lens. A concave lens is thinner at the middle but thicker at the edges. It is opposite to convex lens. It is thinner at the middle and thicker at the edges. Okay. The next one, concave lens is known as diverging lens. Why? Because it can divert the beam of light. See, as a concave lens diverges the rays of beam of light falling on it, it is known as diverging lens. Let us see the diverging action of the concave lenses. How this concave lens diverges the beam of light. See, these are all this is concave lens. These are all the light rays. When the light rays, when a beam of light falls on a concave lens, what will happen? It can diverge the beam of light instead of converging. If it converges the beam of light now, it is known as convex lens. It can diverge the beam of light, so it is known as concave lens or diverging lens. Okay. The next one, let us now study the image formation by lenses. How image formed by a convex lens. First we will discuss about image formation by a convex lens. See, take a convex lens. Place a lit candle at a distance about 50 cm from the convex lens. See, this is the lit candle. Bring the candle closer to the lens. If we bring the candle closer to the lens, we can obtain the image. Bring the candle more closer to the lens. What will happen? We cannot see any image in the screen. Okay. So what did we observe? We observed that as the candle is far away from the convex lens, the image of the candle found is diminished, real and inverted. Okay, diminished means very small. As the candle approaches towards the lens, its image becomes enlarged, real and inverted. But when the candle is closer to the lens, the image found is enlarged, virtual and erect. What is called virtual? We can't see the image in the screen, so it is related to virtual images. Okay. The next one, image formation by concave lens. What is the another name of concave lens? Diverging lens. Why? Because it can diverge the beam of light. Let us study the image formation by concave lens. Say, take a concave lens, place a lit candle in front of concave lens. Okay. Shift the lit candle to different places in front of the concave lenses. white or colored? See, can you guess whether sunlight is white or colored? Let us study the composition of sunlight in this chapter. Okay, see a beautiful pattern of colors in the sky. It is rainbow. The beautiful colors are seen when light falls on various objects. Did you see the rainbow when it will appear on the sky during rainy season? Okay, so these beautiful colors are seen when sunlight falls on various objects. Okay, see, do we mean the sunlight is colored or is a mixture of different colors? Let us understand by some phenomena. I will play one video. See the video carefully, children.
Let us now study about dispersion, which is a phenomenon of splitting of white light into its component colors on passing through a prism. Place a prism on a horizontal surface and a source of white light on its left. Place a cardboard with a small hole between the source of white light and the prism. This arrangement produces a narrow beam of white light. On the other side of the prism, place a screen to obtain the emergent rays on it. We obtain a colored pattern on the screen in the order represented by the acronym WIPCURE. The band of 7 colors, known as the spectrum of white light, is formed because the different colors present in white light get refracted at different angles.
So this video explains about dispersion of light. What is called dispersion of light? It is nothing but a splitting up of white light into its component colors. When a light falls on a prism, it is splitting up into 7 colors like Vijaya. Okay. See the picture. It resembles Vijaya. That is rainbow. So when a white light passes through the prism, it is split up into 7 colors. Its component colors. So this phenomenon is known as dispersion of light. Okay. The next one. I told Vijaya what it stands. See, this stands for 7 colors, namely V violet, I indigo, B blue, G green, Y yellow, O orange and R red. Okay, so these 7 colors can also be seen in rainbow also. Okay, see, this is rainbow. It is a beautiful pattern of colors formed in the sky after or during the rain. When sunlight falls on tiny rain droplets. Why rainbow is formed? That raindrops acts as a prism. What will happen when light passes through the prism? It is split up into 7 colors. Like that, here the raindrops acts as a prism. Okay, so only we can obtain that, or we can see the rainbow in the sky during rainy season. See, rainbow. It can be observed by a person when the sun is behind him. Each raindrop acts as a tiny glass prism, splitting the sunlight into 7 colors. This shows that white light from the sun consists of 7 different colors. Okay, so the sun is a mixture of 7 colors. Sunlight is a mixture of 7 colors. What are the colors? Vijaya. Okay. Is it possible to get white light by mixing the 7 colors? Let us perform an activity to find this. Okay, you can do this activity in your home itself. Now we are prove that the white light is a component of 7 colors. Come children, let us do the activity. For this activity, we need a cardboard. So take a circular cardboard disc of appropriate size. Next one, at the center of the disc, make tiny hole. finally we discussed about sunlight. It is a white or colored